So once you have your spectra imported into CcpN AnalysisMetabolomics module, you can actually begin to explore the variance within your data. If we overlay the spectra by dropping it into the dropped area, we can see that there is a range of variance within this data. What we'd like to do now is apply, through metabolomics PCA, a decomposition of this data in order to establish the variance within the data set. So if I select all of the spectra highlighted here and drag it into the sources window of the PCA panel, that then applies a principal component analysis to all the spectra, which will allow us to see where the greatest sources of variance are within our data. So it takes a few minutes to load the spectra in, but once they're in, you can see we're looking at the principal component 1 and 2 scores plot, and the greatest amount of variance within the data set appears to be in PC1, and you can confirm that by looking at the variance, whereby it will explain that PC1 is up to 60% of the explained variance within the data set. PC2 looks to be just around 10% of the variance within the data set, and by 5 components you're likely over the 95% explained variance threshold. You can also look on the Vectors tab and see in a spectral view how the loadings are affected in each of the principal components, which is quite a nice feature. And looking at the scores plot itself, you can see the distribution of points within the data. If we double click on any one of these items, we can open the spectrum, so we can instantly see which of our spectra is giving rise to this variance. And actually in this data set where we're looking at hypoxic and normoxic cells, you can see the distribution of points reflects the experimental conditions.